Hey everybody, this is Mr. Beckstrom, and today I want to take a look at some examples of half angle and double angle formulas from section 7.6. So here it says use the information given about the angle theta, and we have the cotangent of theta is equal to -3. It says that the secant of theta is less than 0, and it gives us the theta is between 0 and 2 pi, and it says we need to find the exact values of the following, and we want to find the sine of 2 theta, the cosine of 2 theta, the sine of theta over 2, and the cosine of theta over 2. All right, so we're going to need the formulas from section 7.6. So I'm going to go ahead and copy the ones over that I'm going to use today as we need them. So for the sine of 2 theta, we really only have one formula that we're going to need. So I'm going to copy that over, and then we're going to kind of set this up here. So let me go ahead and get that over here. And that is this one right here. So this is the one that we'll use for this one. So in order to use this formula here, I need to know the sine of theta and the cosine of theta, but they do not give it to me here. So let's go ahead and see what they give me, see how we can find the sine of theta and the cosine of theta, and see if that's enough information to get us through some of these other ones as well. All right, so let me start here just by kind of making a little makeshift graph here. You know, I like to do these triangles. All right, so it tells us that the cotangent of theta is -3. So the cotangent, which is kind of the same as the tangent as far as where it's positive and negative, means since it's negative here, I know that the angle theta has to be either in the second quadrant or the fourth quadrant, right? Because that's the only place where the tangent and the cotangent is negative. Now, it also gives me that the secant is also negative because it's less than 0, and the secant is the same as the cosine. And the secant and the cosine, which is the corresponds with the x value, is only negative in the second and the third quadrant over here. So that means that we're talking about the second quadrant over here. So I'm going to go ahead and make my triangle over here in the second quadrant. Something like this, right? And we know that the angle comes out from the origin, so that's my angle theta there. And cotangent, so I'm going to write a little cotangent here. Cotangent of theta is equal to, that's going to be a -3/1. I'll put that 3/1. And we also know, according to SOHCAHTOA, if the tangent is opposite over adjacent, then the cotangent is adjacent over opposite. It's just the reverse. So it is, for this acute angle here, it's going to be the adjacent over the opposite side. So it's going to look like this. So using the Pythagorean theorem, 1 squared plus 3 squared is 10, and this, oh my gosh, hypotenuse here would be the square root of 10. So we can go ahead, hopefully we've gotten pretty proficient with setting up our triangles using the information that they give us. We've done quite a few of these already, so we can set that up. And this will allow us to pretty easily solve all of our other trig functions that we're going to need. All right, so given this triangle in the second quadrant with all three of our sides, we should pretty easily be able to find all 6 trig functions. So I'm going to go ahead and write down, yep, I know now my sine of theta over here, that's going to be equal to, according to SOHCAHTOA, is opposite over hypotenuse, and it's positive, so it's going to be 1/√10. 1 over the square root of 10, so I'll write that down here. And my cosine that I know that I'm going to need as well, cosine of theta, which is going to be negative because we're in the second quadrant, is going to be adjacent over hypotenuse for this acute angle theta here. So that will be -3 over the square root of 10. So for the rest of this, it's really just going to be kind of a plug and play for these different formulas. All right, so for A here, we're just going to kind of plug this in here and see what we get. So let me put A. Let me kind of, all right. So the sine of 2 theta, that's going to be equal to 2 sine of theta times the cosine of theta. So that's 2. The sine of theta is 1 over root 10. So that's 1 over the square root of 10 times the cosine of theta, which is just negative 3 over root 10. And this should just give us, multiplying across, that's negative 6 over square root of 10 times the square root of 10 is just 10. And that just reduces down to negative 3 over 5. So that will be the answer for A, just negative 3 over 5. All right, so for B, we actually have a choice of what formula we're going to use. So I'm going to actually copy all of those over here. So for the cosine of 2 theta, the double angle formula for cosine, we have all 3 of these that we can use. So we have to kind of decide which one we want to use, and it really doesn't matter. So for this example, I'll go ahead and use the first one. Give myself a little bit more space here. So just plugging it in there. So B, that's going to equal, so it's a cosine squared. So I just go up here. Cosine is negative 3 over root 10. So negative 3 over root 10. We're going to square that, minus the sine is 1 over root 10, so 1 over root 10, and we're going to square that. So we're just looking at 9 over 10 minus 1 over 10, which should be equal to 8 over 10 over 10, which just reduces down to 4 over 5. And that's it for this one. So not too bad, and we didn't need any new information there. So very good. All right, now for the next one here, we're going to move on to the half angle formulas, and those are on page, I think we have to go a couple of pages away for that. That's on the bottom of page 506. So for this, I'm going to go ahead and do the sine and the cosine here at the same time for that one. So give me just a second here. All right. Oh. All right. It's not letting me make those bigger, but that's okay. All right. So I got a 4 in there somehow. Oh, I'll ignore that 4 there. Hold on. All right. So here's the 2 formulas for the half angle formulas for both sine and cosine. So these are a little bit trickier, and notice that they have a plus or a minus. So for these, we really have to pick the one that's going to make sense depending on where our angle is. Now notice that if, let's kind of scroll back up to our angle. If we take half of this angle here, we're going to be in the first quadrant over there. So both sine and cosine are going to be positive. So our final answer here should be positives. And if we take the square root of an answer, just kind of drop the negative part off of here. So we should be just looking at the positive part of these. Okay. If we were talking about something in a different quadrant, then we might be dealing with a negative here. But for both of these, since we're going to end up being in the first quadrant here, then we're just dealing with the positive answers. All right, so for the first one here, it's mostly going to just be kind of simplifying these. So this is part C. We're going to have the square root of 1 minus the cosine, which was negative 3 over root 10, all over 2. All right, so what we can do is first combine the top there. So that's, we can write that as root 10 over root 10. And the negatives will cancel out, so that's plus 3 over root 10 all over 2. And this becomes the square root of 3 plus root 10 all over root 10 all over 2. And then if we multiply by the reciprocal of the denominator, so multiply by 1/2, this just becomes 3 plus root 10 all over 2 root 10. 2 root 10. And that would be your final answer right there. All right, and then for D, that plus just becomes a minus there. So you're going to end up getting this. So you'll get 1 plus, and then you'll get a negative 3 over root 10 there, all over 2. And I will let you do the work in there to see how that comes out. But your final answer there should end up becoming root 10 minus root 3 all over 2 root 10. And it's going to be the same kind of process there as up here. All right, I hope this helped. If you have any questions, let me know, and have a great rest of your week. Thanks.